Good morning, everyone. So today we're going to talk a little bit more about hyperbolas. In front of you right now is the answers to the 4 questions from last class. Let's quickly go over it. So for number 1, we have our center, vertices, foci, and equation. So I just want to go over number 1 and then I'll take a look at number 2, 3, and 4 just visually. So the x squared minus y squared, so that tells me it's going to be a hyperbola that opens up sideways, or another way of thinking about it is the transverse axis is going to be horizontal. So let me just draw a quick little picture of a representation of that. So that would be something like this and that. Okay, so then we have a and b there. It's just the square root of 9 and the square root of 25. And we find c by using a squared plus b squared equals c squared. And then solve for c. Now, when we do this, and when we figure out what to add to what, so the vertices, so here are the vertices, that point and that point. And so the center is at 0, 0. And so this isn't drawn exactly to scale. That represents A. That represents negative A. And so 3 units away from the center is the vertices. And that's how we get the 3, 0 and the negative 3, 0 right there. Then the foci, so the foci are inside the hyperbola. So, sorry about that. Let me change. So here's a foci, and I'm just not giving these coordinates because it's not drawn to scale. Foci are inside, and so then it is square root of 34 comma 0 and negative square root of 34 comma 0. So this here represents c, and this here represents negative c. And we'll talk a little bit more about that today. And then we have the equation for the asymptotes, which are here and there. And the formula that you learned last class, k plus or minus b over a, x minus h. And then you just plug in what you know, and then you end up with this equation at the bottom. And then here, you can just pause the video to check your answers. There's 2, 3, and then 4. I'll zoom in a little bit so you can see. Okay. If you have any questions about that, let me know. All right, so attached to the lesson is some filled out notes. I didn't want to have you refill out some notes, so I provided these notes for you. Just a couple things I want to mention here. So the transverse axis, I don't know if it was totally clear in the video, but it's that line. That's the transverse axis. And it goes through the vertices and the foci. And so this picture right here is an x squared minus y squared over whatever b squared and a squared equals 1. So that's opening up horizontally. If y squared is first, then it opens up vertically. And that's kind of what this is saying down here. Let me just erase that up here. Okay, so the way we're going to graph it today is going to be a little bit different because we're not going to graph it by the equations. We're going to graph it by, in the video that you watched last class, they talked about the box. We're going to utilize that today. And then you can do whichever method you feel more comfortable with. I think it's a little bit confusing when we're talking about the asymptotes. And we see this equation, y equals k plus or minus b over a, x minus h. You're like, that doesn't really make sense. But then when you make the box, and then you can just, I'll show you what to do, and then it's a lot easier that way. Okay, one thing I want to mention, so the hyperbola kind of looks like two parabolas, but it's actually not. And I want to show Desmos, your favorite application. All right, so I just made up some hyperbola. The x minus 2 quantity squared over 16 minus y minus 2 quantity squared over 16 equals 1. And if we zoom in a little bit, let's go home. If we zoom in a little bit, it kind of looks like they're parabolas. But parabolas keep opening up wider and wider, and if we zoom out a lot, what happens? It looks like an X. And parabolas will never look like that. And that's because the asymptotes are restricting those branches, you could say. Okay, that's all I wanted to show you on Desmos for now. One other quick thing. So here are the two asymptotes here and there. And you can see they never actually cross, they just approach it. Okay, let's go back here. Okay, so we kind of basically covered all this in the previous video. I'm not going to spend too much time on that. I want to go over some more examples because I want to do some examples with you guys. Okay, so given the hyperbola, x squared minus x squared over 144 minus y squared over 100 equals 1. Find the vertices, foci, and state the asymptotes. Okay, so I want you to pause it, and now I want you to try and work through this problem first, and then see how you did. Okay, so first thing I notice, it's x squared minus y squared. So that means the transverse axis. I'm going to just write that up here. Let's use transverse axis is on the x. So that means it's going to be opening horizontally. So something that looks like that. Okay, so this 144 equals a squared. So a squared is equal to 144. B squared is equal to 100. And so we get a equal to 12 and b equal to 10. And now we want to find out what c is, because c is going to help us find that focus point. So use the a squared plus b squared equals c squared. Plug in what we know. Well, we know a squared is 144. So 144 plus 100 is equal to c squared. C squared is equal to 244. And then we need to take the square root of that, which simplifies to 2 root 61. And I'll let you guys try and figure that one out on your own. You can break it up into its prime factorizations, or you can look at the biggest perfect square that goes into it, which is 4. Okay. So now we have C, we have A, we have B. We have everything we need. Off to the right, I'm going to make a sketch. So I'm going to leave a little space. All right, so vertices. And I'm just going to call them V. So what are my vertices? Okay, so first of all, where's the center? That's the key here. And if we look here and here, we can see there's no plus or minus anything. So the center is going to be at 0, 0. So let's actually write that first. Center 0, 0. Okay, now let's do the vertices. The vertices. Okay, so now the vertices are going to be affecting the x coordinate, not the y. So it's the center and then plus or minus some x value because it's opening horizontally. So what is that x value? Well, it is our A. If you recall, way up here, right here. So we can see that A value is the vertice distance from the center. Okay. So A is, in this case, 12. So we're going to be adding 12 and subtracting 12 from the x values. So the first, let's subtract, so it'll be negative 12 comma 0 and 12 comma 0. Okay, now we have our foci. Foci? Sounds like I'm saying a swear word. Okay, so focus, now we look at the C value, and it's from the center plus or minus C. So let's actually write that out. So it's 0, actually, just kidding. Well, yeah, I guess we can write 0. Sorry, it's getting late. 0 plus or minus C, comma, 0. And so this first 0 is because it's centered at 0, 0. That's where we get the 2 zeros from. And then plus or minus C. So we get, let's see, so C was 2 root 61. I mean, we could just write it like that. So 2 root 61 2 root 61 comma 0, and then negative 2 root 61 comma 0. Or you can write it as plus or minus 2 root 61 comma 0. That's acceptable too. And you can plug that in and give a decimal, that's fine as well. When you're actually graphing this, I would use the decimal because that's going to give you a much better understanding of that coordinate. And I don't know what it is off the top of my head. Let's see, it's a little less than 8. So it's somewhere around 15-ish, maybe. Negative 15-ish. Okay. So let's see, we have our center, we have vertices, foci, state the asymptotes. All right, so the asymptotes, we're going to skip that. I'm going to show you how to do it without the asymptotes. Okay, so we have our x and y axis. And then for sake of space, I'm going to call this point. This is 12, and then this is negative 12. So that represents A. Remember, A was 12, and then B was 10. Let's make it a little closer. We'll call that 10. We'll call that negative 10. Okay, so my vertices, let's use some pretty color here. Let's use a nice little pink. So there's one vertice or vertex, and there's the other vertex. And what we're going to do is we're going to make a box. So this box is based off of A and B. So remember, this was A, and that was B. Remove that. So what we're going to do then is we're going to make a box right here. So and we're going to utilize this box to help us draw the rest. So what you are interested in here are the corners. So let's use yellow. So this corner here and this corner here. And you can just take your ruler, connect those 2 points and make a line. So it looks something like this. Probably should make it dotted, but for the sake of drawing on here, I'm not going to. And then do the same thing for the other way. And it didn't go through. Let's redo that. I think I can draw a little better. There we go. So those are the asymptotes. Okay, let's go back to our pink. Okay, so we have our vertices here and here. And then we have our foci, which are some point out here. That's our focus and our focus. And that is 2 root 61 comma 0. Let me just grab my calculator and do that real quick. I'm just curious exactly what it is. 2 times the root of 61. So 15.6. So a little bit greater than 12. So that's about right. Okay. Remember, the focus should be inside. So then it looks something like this. And you just kind of want to model it so it kind of goes right up against the asymptotes, but doesn't actually cross it. like when we were doing rational functions. And that's it. That's kind of what you're going to be expected to do. I don't care if you can write the equations, if you can, and then you graph the equations, that's fine. But you don't have to. Let's do one more. All right, so given the hyperbola, find the vertices, foci, and state the asymptotes. Again, we're not going to state the asymptotes, but we're going to graph it, and then we can kind of see where those exist. Okay. I'm going to make my print just a little smaller. Okay. All right, first thing I notice, it has a vertical transverse axis, so it's going to be opening up and down. So let me just draw a quick little picture like that. So it's going to look something like that. That means we're going to be adding to the y values instead of the x values for the vertices in the foci. All right, so a squared is equal to 64, and b squared is equal to 25. So a is 8, and b is 5. Excuse me. So then we want to use a Pythagorean, well, it's not the Pythagorean theorem, but it looks like it. 8 squared plus 5 squared is equal to c squared. Actually, you know, I think it is very closely related to the Pythagorean theorem. Now I'm questioning. That's okay. We'll leave that question. You can do a little research and figure that out. And then we get square root of 89. So 89, so c equals the square root of 89. Okay. So we're going to go through this one a little bit quicker. Let's see. So my center is at 3, 2. Common misconception here or error is you think this is the x value and this is the y value. So don't do that. I almost did that. And I probably will do that. Don't do it. Okay, vertices. Okay, so now we want to add to the y value. So 3, and now we want to do, and I'll write it out like this, 2 plus or minus a. That's ultimately what we're doing. We're finding that distance between the center to the vertice. And what is a in this case? A is 8, so it's 2 plus 8, 2 minus 8. So what we get is 3, 10, and, oops, I thought I messed it up. So we get 3, 10, and then we also get 3, negative 6. The foci, again, we're adding to the y values now. So 3, wish the eraser was right next to it. I wonder if I can adjust that. 3, 2 plus or minus c. So that's 3, let's see, so c was root 89. So I'm just going to write it like that. 2 plus root 89. And then 3, 2 minus root 89. And so that's like a little bit greater than 9. Let's see what that is. 9.4. So 2 plus 9.4, 2 minus 9.4. Okay, so now let's go ahead and graph it. All right, so our center, we can draw this one a little bit more accurately. 1, 2, 3, 1, 2. There is our center. Let's use blue. Remember, it's opening vertically, up and down. So let's see here. We have 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. All right, so we have these are our vertices. We're going to run out of space. Bummer. Okay, that's okay. Those are our vertices, and now let's look at, remember this represents A. Always keep that in mind when you're doing that. And now we want to figure out what B is. So, well, we want to graph B. Oops, dropped my pen. All right, so B was 5, so we want to go 5 units horizontally. So we need a 1, 2, 3, 4, 5. Let's use green here since this isn't part of our graph technically. 1, 2, 3, 4, 5 here. So now we can kind of make this box here. Then we can connect those so it looks like that and that. And then the foci are outside here somewhere. I'm not going to graph that accurately for now. And then we kind of go like that, and like that, and like that. And there we go. And there is our beautiful graph on top of our work. Okay, so I think we're going to wrap it up here. What your homework then is to make a sketch including everything in number 3. And then I also want you to try number 4. Notice number 4 is in general form. So what do you have to do here? You need to, you got it, complete the square. Just like we did with the ellipses and the circles and parabolas. Okay, so we'll just leave it as, well, you know what? Nah, we'll just leave it as 3 and 4. That's your homework. So homework is 3. Go ahead and circle those 3 and 4. Okay, and then we'll have a Zoom meeting maybe on Friday to go over things, and then expect the test to be next week sometime, probably on Thursday, if I have my days correct. Thursday. All right. Hope you guys are surviving. All right. Take care.